I write a compiler still for the Elna programming language. The language itself is on the screen currently, so the compiler is written in itself, and we can only use the features that are already implemented. So the language that I use for the compiler is not the complete language, but it is just the current stage. And I slowly move towards record support in the language. So we can already define records, but last time I tried to implement the field access. And for the field access, we need to annotate all expressions with the type of the expression in the abstract syntax tree. So we decorate the abstract syntax tree with type expressions, with types of that expressions, so we can get a type of the record and calculate the field offset, so we can access the right field of a record. When we handle field access, there are actually two cases where field access is used. The one is the record field access. So if I basically have a record X and want to access its field kind, then I write variable X and then kind. But there is also another kind of field access, and this is enumerations. So if I see enumeration here, the enumeration, for example, this one, Elna Alexa class, starts not with the variable name, but with the type name. So if I want to use one of the values of this enumeration, I have to write Elna Alex class invalid, for example. And from the point of view of the abstract syntax tree, it's actually the same structure. So we have an identifier on the left side, or expression on the left side, and we have a field or another identifier on the right side. But these two things, so record field access and enumerations, are pretty different, because a record field access just has simple expression on the left side, and enumeration has a type name on the left side. So we need to distinguish these two cases. So field access is a designated expression. Designated expression means that this expression can appear on the left side of an assignment, and we just going to look for the type path that handles the designated expressions. It is this procedure, and what I have done the last time, it is exactly what I just described. So I check whether the thing on the left side is an identifier, and whether it identifies that this is a type. Then I save the type of this enumeration as type of the expression, and if it is not a type, then it is assumed to be field access and it is not implemented yet. And the second place where we use this thing is basically code generation, intermediate representation generation. It will be as well TAC designator, and this is this procedure. I check here for the field access expression, and if it is enumeration, then we can already handle this. So I compile it to the value of the enumeration, and if it is a field access expression, then I have temporary stop here, so it just always evaluates to a 0. Then I added a new stage to my compiler, so the current stage we work in is the stage 16, and I created a new one, stage 17. It's an exact copy of stage 16, but I have an additional function here that just gets a variable of type of a record type as parameter and accesses a field of this type. So it is just for testing there, so we can see that it compiles. And currently, because of that stub I showed previously, it's just always compiled to 0. So field access expression, but we want, of course, so it compiles to a field access. So we need to decorate the abstract syntax tree with the type of the expression. So the type of x is this one here, and then we need to calculate the offset on this variable, so we can access the actual value of the field. So let us go back to the type designator function, because this is the first thing that we need. And exactly. So now on the left side, if it is a field access expression, then it is not always an identifier, so it isn't always a variable. It can be also a pointer, so we can't just check the type of x, but we should visit the whole expression, and we can do it by this ELNA type simple expression procedure. So I suppose we can uncomment it. It gets designator base as argument. Designator base is basically designator base is the left hand expression here. So we get it and we visit it with this ELNA type simple expression procedure, and I want to check whether it compiles. So it will now compile the 16th and the 17th stage, 16th because it has changed, and the 17th because it depends on stage 16. So it compiles. Now we have evaluated this expression, and the type of the expression on the left side should be basically saved in this designator base node, and we can get this type, but I'm not sure what variable I can use for it. Do I reassign it here? No, I don't. Let us introduce an additional variable, I think. This is basically designator type, or we call it aggregate because it is a record in the usual case. So we define a variable aggregate type, and we save the type of the expression in this variable. So we uncomment this line and save the aggregate type in this variable, get type decoration from the designator base, and it should be actually a record. I had spatial debugging code somewhere, so we'll remove it from here and move it in here once again. And what I want to see, so we get the type of this expression. Get type decoration will return a type. It will return this ELNA type, and every ELNA type has a kind with exact kind of this type, so enumeration, record, and so forth. So let us read this kind. Once again, we will not check this at the end, but we do it just for testing, so we see that that we have a correct value here. So ELNA3, what was it? ELNA type, get kind from the aggregate type, and let's just print it as a comment into the assembly. Then I have a rake convert task. It just copies the stage 16 into the stage 17 and adds this test function at the end. So it makes the testing a bit easier. And we have an error here because we don't have aggregate kind, because it is called type kind. and it fails. It definitely fails. Okay, let us print the pointer to the aggregate type. We can put P in here and remove this line for now. And where will be it printed? Actually in build code stage 17, I think. Exactly, so it prints a pointer. And the pointer is set. And the same should be true for the validation state. Yes. So actually it always retrieves a pointer, so it is never nil. This is fine. But why I can't retrieve the kind of this expression? It does seem to work actually. And that means that I can write type kind in here. This is an integer. If we reload the assembly file, then it generates 3. Let us go into stage 16 again, and somewhere we will have this Elena type kind. Let us look for record. That was not very smart decision. Probably array. Exactly, this is kinds of the types. We should rename this one and call it Elena type kind. It has record, and the record is the third enumeration in the list, so 3 is correct in the output. And here we can be sure that that our type is really a record type. So we can look for further fields, and that was Elena type. So we just have kind and size, but since it is record, it has also members, and it has the number of members in the enumeration. And instead of getting the kind, let us read the length now. So we read the number of fields in the record, and we print it the same way. And we compile it once again. And it fails because, of course, the record name is wrong. So this record getters and setters is a temporary solution. We want to replace it with the field access we are currently implementing. So they will go one day, I hope. That's probably the wrong assembly file. Yeah, we actually need build valid. We haven't updated the stage 17 compiler, therefore the assembly looks a bit different. Okay, let us just edit this one. It's the same but in the boot directory, and it prints 2. Let us check whether this is correct. So we go to the stage 17 and the type is ELNA3 expression, and it has 2 fields. So this is fine as well. Now the only thing that we need to go through these field definitions and find the field that we need. And get its type, so we can calculate the type of the whole expression. We only have name pointer and name length. Let us create a variable field count and probably current field as well. I should probably split this stuff into a separate procedure, but we take care of it later. So here they read the field count. That looks fine. And current field will be basically ELNA type record get members. Now the funny part is that I haven't updated. Let us see where these members are set, but I haven't updated this part of code for some time, so it doesn't work with records, but it actually works with chunks of memory. So we hadn't records all the time, and before I introduced records I just worked with allocated chunks of memory, and so here we allocate 16 bytes. In the first word is the name saved, then the length of the name, then the pointer to the type, and then probably nothing. Is it the right function? No, I don't think so. This is record type expression, but we actually need ELNA type record set members. That looks more like it. I would suggest ELNA type record size. I would suggest that we update this part of the code a bit. So each field entry is 12 byte long, and this is basically the same. So the first 4 bytes is probably the name, the second the pointer to the name, the second is the name length, and the third one should be the type of the field. So let us go to the type definitions, and we go to the type, and somewhere we define ELNA type field. It is a record, and this record has a name. Everything is a word currently, since it is only supported type, so the language in its current stage is pretty untyped. We will add type checking and additional types later. And type. We can't use type since it is a reserved keyword, so we call it field type. That should compile. So what it allows now, we can so actually I should replace this 12. So it allocates basically an array. After the parsing, we know how many fields are in a record, so the parser saves the fields in a list. But after the parsing, we know the amount of fields in a record, and we can just calculate how big should be the array of all fields, and we just get the member count, which the parser knows, and multiply it by the size of the single field definition. And field definition is exactly the word I was looking for, definition size, and we just assign field definition size is basically there is now another auto-generated function. It's ELNA type field size. It returns the size of the record. This one will be replaced later as well with so-called traits. It's basically a size of operator, so we will write it later as hashtag size and then the type name. This is a future syntax, but now we go with this auto-generated size function, and we put it then in here, definition size. Oh, field definition size, element type field size. I have forgotten what the error was. Undefined reference, element type field size. Element type field. Okay, we had to update the stage 17. And already we got rid of hard-coded record size. So now we can use getters and setters instead of manual field offset calculation. So basically here we set the name of the field to the memory start. Yeah, abstract syntax tree uses uses almost the same structure for the fields, but we look at this one later. I actually think we can try it in a type field set, and the first field that is set is basically this name field, so it will be set name, then we pass the name of the record to it, and it will be basically this member array start. Member array current, I think. I hope I don't increment this thing. I do. Well, member array current, and the second argument is basically the value we want to set, and this value is the reference memory start, and probably I can remove the first line but not the other ones. So let us I'm in the wrong, of course I'm in the wrong stage. So this is stage 16, and we want to close this one. Probably we should repeat this once again. So we go into the stage 16, and we need again this field record definition. This is not type record set members I set, and it was here, and we write field definition once again of type word. then we assign a value to it. Field definition is Elna type field size, and we replace this 12 with this size. A fast check that this works. Seems so. Let us update the stage 17 and do it again. It will compile only the last stage now. And what we have done is that we called this setter function ElnaType field set name in the member array current to the memory start, and we tried to execute it and it didn't work, but this time it probably will. Yeah. The actual test is removing this line. We still need to increment the memory start, because memory start is actually a pointer from the abstract syntax tree, so we won't change it now. But this line can be commented, and we can set the length, but only after memory start is incremented itself. Then this is the length, and we set the length again to the new memory start pointer value. It should crash because the point offset doesn't match anymore, so it crashes because I removed +4 here, and to make it work I need to add +8, I think. And we can remove actually this line. Yeah, it works. So let us remove the stuff in the comments that we know we don't need, and we only need to set the last field. So basically memory start, that's fine, but we do not want to do this, and we set then the last field. It was field name, field type, and we set it to the. This one is actually different because we need to convert abstract syntax tree type representation into actual type representation. So we need probably an intermediate variable, memory count. Yeah, let us call it field type. And first we already move the pointer, so memory start should point to the type value. So before we set the type, we should actually get it and save in the new variable field type. Memory start should be fine here. And after that, we can assign basically this field type value to the record. Member array current plus 4. So as I said, the memory start is a list, so it basically saves the next element in the list as the last word in this field record, and it actually assigns memory start to the pointer of the next list element. That's fine, I suppose. But we also, since we have an array of fields, we need, and we don't have any support for dynamic or static arrays in our language yet. So we have to assign the size of the record field, add the size of the record field to this array pointer. So we basically move to the next element in the array, and we save to the size. Field definition is wrong. It should be, of course, field definition side and not field definition. Field definition size. Field definition size. And we want to add this field definition size to the member array count field definition size. And it works. So we still have a bit of pointer arithmetic, but at least a bit less than before. And probably we can now get the type of the field in the previous place. Where were we? It was something like type designate, wasn't it? Exactly. So we have a pointer to the first field in this field array or field definition array, and we have the field count. To test it, we can just print the name of the first field and just look what we get. So we get these two variables that are unused, and we read this would be a type field, I think. Type field get name and type field get length. Type field get length from the current field. Current field, and we try to output it here. I have no idea what the syntax was. and first the size of the field and then the name pointer. So build boot stage 17 CLS, and it prints kind, and this is really the first field, so it's basically the correct result. Actually, we can check field count shouldn't be 0, so we can basically check that field count is unequal 0. Then we can read the value from it, and we end the statement, the if statement. I don't know what this else is. I think we need two more variables for the name. So actually assigning these two variables is here we get the value on the left side, but now we need the value on the right side. Yeah, we need basically additional variables for the name and value. Current field count aggregate type. Field name pointer word and field length, field name length word. The current compile implementation uses a static stack size, so the procedure cannot have endless parameters, but the parameter count is limited, so we have to look that we don't overwrite the stack with some garbage. How many variables are 6, 8, 12. I hope it's fine. Exactly. So here we have the field name, and we introduced basically two new variables. Let us save the field name in these new variables. So field name pointer and field name length. And we need the name on the right side of the field access expression. So name pointer is ELNA3 field access expression, I think. ELNA3 expression get type declaration. This is not ELNA3 field access expression get. Let us go back to the beginning, and we go to this field access expression type, and this type has field and length. So field is a field name, and length is the length of the name. So name pointer is then get field from the parser node, I think. Get name designator base, that is not from the parser node, I think. Aggregate, yeah, from the parser node. And we get the length. And we can try to compile this again, and now we should just compare the field name we are looking for and the field name we currently add in the array of field definitions. So basically we just need a memcmp function. I actually had a function for string comparison. It was, I think, string compare, and this string compare takes name length. So we can just call this string compare function. We pass name pointer name length and field name pointer field name length to this procedure, and so it returns 1. I think that then the both string equals. And what we can do, we can just put it in another if statement. And we write here if and else. What is this? And try to compile it. So we are looking again into the generated assembly. It will be built boot stage 17 compiler s, and it prints if. That's actually correct, because the stage 17 access the kind field, and kind field is the first field in the record, so this is actually correct. And if we change this thing to LNet3 expression is it, and the second one is type decoration. So if I change it to the type decoration, or let us do it a bit differently, we go to the rec file and we look for this type and change it here to the type decoration, and then we convert stage 16 to 17 and run break. Then it prints else, because type decoration is the second record and we only check the first. Actually, if string comparison succeeds, then we are already there and we don't need to do anything else, so we can just return, so to say. We actually need the type of the thing, but let us implement the loop first. So the second condition, if it is else, so the things don't match, then we need to jump somewhere else, probably in here. I prefix the labels with procedure name, so we call it field. The language doesn't have loops for now, so we use goTo. And if the field couldn't be found, then we jump, probably after the output, we just jump to this label. Without the period at the beginning. But we have to decrement the field count first. So field count is field count minus 1. This is the one thing. And the other thing that we of course should actually we don't need this if condition. Yes, it is error checking, but we do not do error checking currently, so we just assume that the field name is correct, and then we don't need this check. Actually, I put a comment around it first, but it actually can be removed for now. Later we will need it again. So we current field, yeah, actually the record, the label should be defined afterwards, probably somewhere here, and we read the field count and current field from the aggregate, and we need also jump to the next array element, and it will be current field plus elna type field size. Wow, it compiles. I haven't expected that. Let us, exactly, it looks actually fine. So it first checks the first element and prints else, because the first element is kind and not the type decoration, and after that it prints the second element, compares it, and the field name matches. Yeah, as I said, we remove this for now. So now we exit this loop, so we jump only here. We can remove this debugging code from here, and now our current field points to the field type that that matches what we are looking for. So basically we can finally assign the base type. We can finally assign the type of this field to the base type. Elna type field get field type from the current field. It will set the base type, and base type will be set at the end to the base type. And since we handle both enumerations and records now, we can remove this comment from here, and probably the compiler will crash because it will do nonsense during the code generation. Just to check it, we set base type to nil, so I can be sure it is really where it fails. Yeah, it compiles this way. So we go to the stage 16 again, and we go to the code generation. This is TAC designator, and it basically checks whether the type in the expression node, whether it is nil. But since we always set the type, it's never nil anymore. So we should actually probably so we have field access, and it means that other type is an enumeration type or everything else. So the best way to check this is probably, do we have something where we can save the kind, not kind? What is not kind? Not kind, parser node. Do we need the type name here at all? Name pointer. Do we use it? No. Let us just reuse this variable. We will rename it later. Expression type. Get type declaration. It will be Elna type, and Elna type will be get kind, so we can get the kind of the type, and we basically want to remove this one. We don't need it. And if expression, if name pointer is not type kind enumeration, then we generate 0, otherwise we handle the enumeration value. Yeah, it doesn't seem to work. So now we can get rid of this name length variable and we rename name pointer to something like type kind. So we don't need name length anymore, and this one is called type kind. Type kind and type kind. And we want to swap the handling, the branch handling, so I compare it here with the enumeration and handle the else case here. It is just a bit more readable for me. We can leave it as is. So I think that we are done. No, we are not done here. But I will leave this stub here, so we only need to calculate the offset and set is address to true, because basically field access is an addressable expression and it should work, but I don't know how much time it requires, so we will probably do it the next time. The one small thing that I want to do, I want to rename this type kind to add a prefix to it. I think I wanted to convert the stage 17 and just look if it works as well, if I haven't done it already. Yes, it compiles as well. So to be sure, we exit and we save our changes. So I basically just save it, and we had modifications of rake file that aren't important, I think. Now I can revert at least if something goes wrong. So we go to the stage 16 and we find this type kind thing. I wonder how often it is used. Not very often, so we rename it to the Elna type kind. I do it manually because there are not that many usages. And that's it. We compile the stage 16 once again, then and 17 too, but the old version of it, and we copy the stage 16 to 17 once again and recompile the last stage, or our test stage, stage 17. It compiles as well, and I would say that we leave it here for today. I I know that there is not that much information about the language itself. I actually have pretty good idea what the language will look like, and I started to work on describing the language and its features, but it will take some time. But I started to write the documentation, and I will do it step for step. And I also will add links to my videos, so with the source code. But as I said, I can't do it all at once. I need some time, but I will add more information about the compiler, the source code, and the documentation step by step. And I finish here today.